Let's begin with a general introduction to the educational trainer. This is a fully functional vehicle with a hybrid drive system, which includes an internal combustion petrol engine and an electric motor. Under the bonnet, we see the internal combustion engine, and beneath it, in a less visible location, there is the electric motor and inverter. This EV/hybrid vehicle can also charge its battery from a household outlet, making it a plug-in model. Inside the trainer, a mobile breakout box is integrated for measuring various system signals. This box allows measurements from both the internal combustion engine system and the electric motor system. Next, the trainer features a safety lock to prevent the vehicle from moving or driving during training. Even if the vehicle is set to drive mode, it will not move, ensuring safe learning for both students and instructors. Here's the charging socket for plugging in and charging the high-voltage battery. On the outside, a safety switch is integrated for additional security. The vehicle is fully functional and operational, making it an excellent training stand for a wide range of training activities and practical tasks. Students can easily start, operate, and drive the vehicle. It also allows detailed analysis of many systems, components, and functions, giving instructors and students comprehensive learning opportunities. Let's try a simple example of possible measurements. First, let's use a multimeter for basic testing. Using the provided wiring diagram, we identify the measurement point and connect the wires into the dedicated slots. In this example, we test the accelerator pedal signal. From the wiring diagram, we find the wire connections, connect the multimeter to the breakout box at the labeled slots, and measure the accelerator pedal voltage signal. As the pedal is pressed, the voltage changes can be observed. Another example of a practical task is using an oscilloscope to measure the fuel injector signal. With the wiring diagram, we identify the exact connection slots on the breakout box, connect the oscilloscope, and then observe injector operation signals in the software during engine operation. Furthermore, one of the key features of this trainer is Wi-Fi wireless fault simulation. To connect, first use Wi-Fi and the dedicated IP address. In the open window, you will see a general description of the vehicle and its specifications, detailed wiring diagrams, and the fault simulation buttons. When you press on a system, the button turns red, indicating that the fault is active. Then we can connect to the OBD diagnostic socket. Using any diagnostic software, the vehicle's systems can be scanned, fault codes can be read, and faults can be erased. For example, after scanning the vehicle, we detect some faults and clear them. Instructors can simulate faults, giving students real practice in identifying and solving system issues. The hybrid educational trainer provides a complete and safe environment for learning modern hybrid vehicle technology. With real components, diagnostic capabilities, a breakout box for measurements, Wi-Fi fault simulation, and OBD diagnostics, it allows instructors to simulate real faults and students to practice system analysis, measurement, and repair. This trainer combines practical hands-on tasks with advanced diagnostic tools, giving a full understanding of both internal combustion and electric drive systems.